All right, so today we'll study layer 2, and the next class we'll study security for layer 2, because you need to understand the basic principles of layer 2 technology, and we'll focus primarily on Ethernet. Okay. All right, so I sent you this email, and only one person, Aryan, has responded, right, out of 100 plus people. So please be attentive and responsive in case you want to learn. In daily life, we can see how many threats are proposed, how many threats come to us, cybersecurity threat, and many of us get fooled. Now, what was the issue here? I mean, you are proposed by some gentleman that, somebody that, there is an investment opportunity, and there is a website or maybe an app, and then we will give you some training, and then you need to deposit say 1 lakh, and after some time you will continue to get say at the rate of 25% per year. So what will be the issue? I mean, of course these are all, as Aryan mentioned, social security issues, right? Social engineering or social engineering issues. Because if somebody is fooling, and somebody, see, if it comes to you and you start trusting the unknown person, right? And in order to gain your trust, the person may be fooling you also by, in fact, showing on the website your money has increased by 25%. You know, after 6 months, maybe 12% or something like that. Okay, and you get fooled and you put more money into it, and then so on. When you try to withdraw, then you come to know it's a fraudulent site. So this is surely a social engineering issue, but at the same time, how do you validate this?
Since the website is not regulated by some third party, that's why it's a problem. Like,
That's right.
for
No, but all websites are regulated by third parties, no? I do trade with my stock trading is with multiple companies, including ICICI Direct, Zerodha, and many others, right?
like for example, any stockbroker has to be regulated by SEBI or in India.
Yes, yes. Very good. Very good. So essentially, the person here has not done authentication. You must, and half of your problems are solved of cybersecurity, almost half in daily life, if you to authenticate the person who is at the other end. I gave you another example of one girl who got a phone call from somebody that the courier you have sent has drugs. Now, had she not authenticated the person on the other hand, that is actually police guy or not, and it's very likely she would have got fooled by 1 or 2 lakhs of rupees, right? So you have to always authenticate whom you are talking to and why. So you may be getting large number of phone calls for something or other. I have recently got a phone call from somebody says that my PF, Provident Fund money, some portion of the money is stuck, which is true, right? He says that I will get the money released, and so on and so forth, right? So the question is, is it, I mean, now I have to authenticate the person. Am I talking to government employee or non-government employee? So I asked couple of questions, and I realized that the person is, some agent or some fraud. Then I asked him that, I am giving a phone number to cybersecurity cell, and then he started apologizing, right? So the point I am trying to make is that in daily life, you have to authenticate. Okay. What is the issue here? Now, this you would have read in the newspaper, right?
The private key is made public by her.
Yeah, so basically she has leaked her credentials, right? Like user ID password, not public private key. There's no question of public and private key. She would have leaked the credentials like login ID and so on and so forth, right? Okay, it's not public private key. It's just any. I mean, you have login account into IIT Mandi's website or something, and you pass it on to your friend, and friend tries to do some fraud or mischievous actions, right? Okay, so this is called insider threat. Insider threat is significant now. Insider, it means that in the system, like your IIT Mandi, or it could be organization, any organization. An employee inside knows a lot of things. Okay, like secret database or sales database or IPR. IPR is intellectual property rights. Like company has developed something like Coca-Cola. What is the formula for that? Internal employees may know that. Okay, and pass on this information to outside world. Right, the code you will write for the company you join is not your personal code, it's company's code. Company has paid money for you, and you will pass on this to your spouse or your friend. It may not be appropriate, right? That's insider threat. Or I'm giving an example. I mean, suppose you join a company, big company, and your friend says, "Yeah, let me see what your company's database look like. What is the code like?" And you start coding with him or her using the same credential login. That's also insider threat. Why should anybody not part of somebody who's not part of organization look at something inside? See, any organization earns money because of its own IPRs or intellectual property rights, something they have created. And why should anybody? And another insider threat is that when you or somebody who has joined a company, knows everything about company, goes out and then starts still use that login credentials for login and doing some mischievous things, right? For example, somebody may delete some important files or may corrupt some files or steal some data, pass it on to somebody, or sell user ID login password ID to somebody else. That's also insider threat, and it's very common. It's very common, right? Many people do it for various reasons. Some people may sell it, like I mean, very often I get a call from somebody that why don't you deposit money with us? I said, I don't have money. But he says, no, we know that you have money in certain bank accounts. How do you know it? Question is that how, because very often the bank employees leak this information to outside world. Okay. Yeah, similarly, your password, user ID and password from any company, hash password, of course, gets leaked. Because for every password, if somebody is getting 100 rupees, so ex-employee of bank who has all this database would have copied in somewhere, will sell it in the open market, right? Okay, so insider threat is significant part of overall threat. And when you join a company, you should be very careful about it. You should train the employees. If you start a company, you should train an employee not to reveal. Many times it happens because employees are not aware of that, what is their rights. Okay. So now if you look at the statistics, then you can see that, now it says that which cyber threat poses greatest danger to your enterprise and data today. And you can see the insider threat comes number 3 after ransomware and I think is a phishing. Uh, so ransomware, phishing are top 2, and then insider threat. Your own employees or because of some reason, emotional reason, maybe they are angry with the company, they can delete the whole database, delete the whole IPR, millions of worth of software they can delete. And that's the reason companies have to make sure that these insider threats are minimized. You can't assume that everyone who's working in an organization is honest guy. Okay, and this is true for all over the world. Okay. Now please go through this statistics, and it says that why people do this, right? Right? I mean, like employees stealing data for financial gains. 28% employees steal data for financial gains. Now, this is not 28% of overall employees. Consider the number of breaches that have happened in an organization and then find out the reason. Then 28% chances are that employees have done it for financial gain. But we can't say that 28% of all employees will do this. Okay. 30% employees leaking data to harm the organization. Why should anybody would harm the organization? Somebody is being sacked, for example, for some reason. Okay, may be angry and can do this, right? But this is all criminal offenses. See, anybody can get sacked, right? It's very common, right? Sacking do happen because organizations run for profit. There's no charitable organization, right? There's not run by government like your institute. It doesn't matter to your institute whether there is recession or no recession, whether it's and so on and so forth, right? It's based on some funding which it gets from somewhere, right? But organizations run only for profit and growth. If they, ultimate aim is that through shareholders they have to give money. Shareholders will cry if company doesn't grow and does not have profit, right? So if profit reduces, they will ask people to leave. Okay, it could be anybody. Okay, and many of you will face this in your career, and you'll have to be prepared for that, of course, financially and emotionally. Okay, so these are some reasons why people do insider threat. But if you are ever sacked or asked to go, never do these activities, because this is all crime. Okay, all right, so now coming back to our own topics. So we are still in layered architecture because internet works based on layerings, like physical layer, data link layer or data layer, then network layer, then transport layer. So these are the 4 layers, and of course on top of these applications, right? So these are the layers, and we have seen the advantage of layering because each module works independently of other. Of course there are interfaces between the two, but we simplify the design. We are making it more modular. Okay, all right. And other thing is that this model runs. Now IP is basically, internet is basically IP layer. So so if IP layers remain constant or with little changes, anything that happens inside, like Ethernet, for example, is data link layer. Now Ethernet speed has changed from 10 megabits per second to now say 10 gigabit per second, right? So internally technology can evolve without impacting anything on higher layer, so by providing the interfaces constant. Okay, so that's another great advantage. Now what is the disadvantage of all this? Disadvantage, so this is what different layers, and point is these layers work without knowledge of each other, right? This layer works with, the data link layer works with minimal interface with the lower layer, and what's happening inside is data link layer is not aware of, right? And that's true, that's how it is designed. Okay, now what may happen is that suppose this gets compromised, some security perspective, then all other layers will not know, but all others layer will be impacted. Okay, so now this has to be handled. So there is a domino effect. All right. Okay. So now we'll start with layer 2. We'll look at security for layer 2 and then move on to higher layers. This is what any internet architecture looks like. Okay, and we have studied that, right? Like various hosts like iPad or mobile and devices are connected to a router. Okay, and these routers are internally interconnected to each other. Okay, in ISP cloud. Okay, ISP network and so on and so forth, right? So now where is the link coming into picture? These are all links. Like your host may be connected to the router through ADSL or DSL or telephone line. Okay, telephone line disguise, telephone line for data communication, or they may be connected over Wi-Fi, or it could be connected over Ethernet, which is a copper wire or fiber wire. Okay, and can you please mute yourself? Okay, all right. Okay. So these are the various links. Okay, it could be Ethernet link, or it could be satellite link, or and so on, or Sonnet link, and so on, right? Okay. So there are various kinds of access technologies, or which is essential layer 1 and layer 2. So fiber, cable, Wi-Fi, and cellular. Okay. So these are various links like dial-up modem. We used to do 20 to 30 years back, ISDN, DSL, which is nothing but cable, telephone cable comes to your home, and you do DSP, frequency division multiplexing, and take out one channel out of this. Okay, it's called DSL line. One channel or one overall bandwidth that's available on wire. Keep something for telephone communication or voice communication, and remaining you can take it out for data communication. That's called DSL, digital server. And then cable TV, that comes to home, you use only 5 megahertz at a time for a channel, right? But maybe it may be having bandwidth for 200 megahertz. Let's assume that you have 50 channels, or sorry, 20 channels, then you have 100 megahertz use, still 100 megahertz is available, right? So that's how you use cable TV, or directly fiber can come to home. These are all links, right? Okay, and you have this kind of modems or routers, right, at home, and you see have this kind of wires, uh, and we have, this is the physical layer, all these wires, and top of that we run data link layer. Okay, so now this is typical internet model. Now we see that first 3 layers, physical layer, link layer, and network layer, are implemented everywhere, because network layer is responsible for routing. Okay, and it means that all routers in between, let me just go back. Here, okay, all these routers here will have 3 layers: physical layer for the link here, okay, physical layer, data link layer, and network layer. So network layer is required because otherwise it will not be able to route packets. Okay, all right. And where do we require all these two? Now routing, it means the packets come to a router and it sends it to the next router. Okay, that's simple. Okay, but it may drop the packet. As we have seen, internet does not provide any reliability or security. Okay, it's just best effort technology. So all these routers in between that use these 3 can drop your packets. Then somebody or leak the packet to malware in between. Okay, and when if you look at, I mean, if you read, what services are provided by internet service provider, they will never say that we will provide you security or reliability, because that's not the internet model. Okay, then responsibility of providing security and reliability rests at the end. Okay, all right. So let's look at. So the now question may be that why do we need security at link layer? Of course, I mean your device right now, like my device is connected to Wi-Fi router. That's also link at the host side. So now I need to provide security even here at the endpoints. Okay, similarly, ISPs may do something, but it's not mandatory for them. Okay. All right. So now if you look at all these three are implemented everywhere, it means that okay. But these two, depending on link, whether it is a Wi-Fi or Ethernet over copper or Ethernet over fiber or something else. Now here the medium changes, the physical part changes, right? Physical part like copper, fiber, or air, it changes. So, right, and then link correspondingly, we'll have to run different protocols. For Wi-Fi protocol is different, Ethernet is different, and so on. Protocol says that how do we make the frame or packet, and what are the different parts of it, so that other side can interpret that. Okay, clear? Now this may be different depending on where your packet is going to. For example, just a minute. Wow. Here, all these are different. All these are different. So this corresponds to first two layers. Okay, physical and data link layer. Okay. Now network layer is the same, because now this defines how packet should be routed. Okay, it defines nothing but IP packet format, how IP packet will look like, and other protocols like OSPF, BGP, etc. for routing of packets, so that one router knows if packet comes for a destination, which particular router is to send it to if there are multiple outgoing links. Okay, so now the model looks something like this. Okay, each intermittent router will have only these layers. Link layer, of course, coupled with physical layer. It's not shown here for some reason. Okay, and only endpoints will have transport layer like TCP, UDP, etc. Okay, all right. Now the single packet, we have already seen this, when comes from top, application data comes in. Okay, then transport layer header is put into the like TCP header. Then it comes to IP. It can encapsulate inside IP. So IP header comes into that, and this IP header is given to link layer. So Ethernet header or link layer header comes in here. Okay, now this is the model. So we can see that we are here now in link layer, right? And this is the typical format of link layer protocol, or we can say Ethernet, for example. Now note that at any layer, the destination, if this is a link, for example, this source and this is the destination, then there will be source address and destination address. Although these are the two ends of a wire, still we'll have to give address. And in Ethernet, for example, each Ethernet card will have its physical address, or that's etched into or programmed into the card, so interface card, right? Okay, so this is called MAC addresses, media access control address. So it's called source address, means this address of source or physical address source, destination address, physical address of destination. Okay, and the content it should carry, right? There's something that comes from top like this one. Okay, and apart from that, it should have some information of what we are sending on to me, right? Whether it is what is a higher level protocol. For example, here type will be IP, because Ethernet can be used not only for IP but other protocol. It's also like IPX, it's another protocol. Okay, all right. And we in general at link layer, we call, instead of packet, we call something called frame. So you'll see the vocabulary changes here, packet to frame at link layer. And when we move up, then we call it packet. Sometimes we call it datagram also, but we'll in general restrict to frame and packet. And we may also interchangeably use the terms. It's basically the same thing. Now, this is how your packet from A reaches this packet to D. Okay, and the routers here decides to take this path based on routing algorithm they have. Okay, now this is a path. Now the question is, what are the links here and what changes, right? So we can see these are the links. Okay, and these links can be different. For example, first link is Wi-Fi, second link could be something else, and so on and so forth, right? Oh, just a minute. Okay, now first two layers here could be different. If it's a Wi-Fi, it could be air, first physical layer is there, and top of that we have Wi-Fi protocol. Now second layer here could be normal Ethernet. The first layer would be say copper, and second layer will be Ethernet. Okay, or Ethernet is basically, it will run a protocol called CSMACD. Third layer could be something else. It could be SONET or whatever, or maybe Ethernet over fiber, and then it will have physical layer as fiber and second layer as Ethernet. Okay, and so on and so forth, right? So now the packet, like your mom's laddu packet, she gives it to a postman who comes over, and then postman will put inside another box, and like here the postman will put inside another box, write the address, which is the physical address of the link, the recipient at the end of link. Like it will be a local post office. Okay, now local post office address will be written inside bigger box. Now at this local post office, this box is removed, an external box is removed, and whatever checks are done, and then inner packet, laddu packet is taken out, and then postman will look at, or worker will look at the destination address, okay, and decides based on some information they have that will go over this path, puts this box. Now they know that destination address is something, will put this inside another box. Okay, and this box will have destination address of router 5 or GPO, for example, General Post Office or Central Post Office. From there it will go. Okay, now once it's received at this place, they will take out the inside box. Okay, now this IP address here or your destination address is seen. Okay, and now there is a air link here. It will put inside another box, and here they will write at end of this, say for example, end of this link, for example, from this is Delhi, then Chandigarh address. Okay, and so on so forth. It's delay goes on, right? So now this internal IP address is used at every point, and then is put inside another envelope depending on what technology, link layer technology is using. Okay, all right. Any question? So what is the responsibility of link layer? Is framing and transmission of collection of bits into individual messages. The network layer is giving IP packet, and then it has to put that inside a frame, right? And now here there will be header, the source address, destination address, and other fields. Now these are this source and destination address corresponding to a link. Okay, and inside will be IP packet. All right. All right. Now link could be a direct link like this one, or it could be through a switch. Like then if it is through a switch from one point to another, then we call this a local area network. Okay. All right. So for data link layer, we call a protocol. How to access the link is called medium access control, MAC. Okay, and protocol corresponding layer 2 protocol is generally called MAC protocol. Okay. All right, so responsibility of MAC protocol is transmitting and receiving frames across link layer, error detection and correction, and we have to define, of course, addresses, link layer address like Ethernet addresses. Now you can find out for your laptop what is your Ethernet address, right? Okay. Okay, now Ethernet is de facto layer 2 technology, so we'll study that in very brief. Okay. All of us are using Ethernet or wireless Ethernet. So Ethernet started with very simple concept, right? And it was invented in Xerox company, and they say that there is a thick wire here. In fact, I have used Ethernet IIT Madras when I joined. I mean, Professor Gonzalez, who was your director, has laid first time the thick Ethernet connecting the whole department. It was sometimes in 19 maybe 89 or 90 sometimes. Okay, so there is a thick wire that goes through the building. It's called thick Ethernet, and now you have to connect computers to that. So you will put a small hole, okay, and connect your machine here, and there is a something called transceiver here. Okay, all right. So this is not just a simple probe, but with some electronics into it. Now you can receive and send packets through that. So the number of machines can be connected like that. Okay, and there is an endpoint here, and the length of this cannot be more than something. Okay, so now, but since then, this was kind of 10 megabits per second kind of technology. Of course, it started with 1 megabits per second. So now 10 megabits per second to 100 megabits per second, then year 2000 becomes gigabit per second, 10 gigabit per second, 100 gigabits. Now it's more than 400 gigabit per second. So that's how Ethernet has evolved. Okay. All right. Now Ethernet frame is also being used not only in local area network but also in wide area network as a layer 2 technologies. Okay, I will not get into that, but this slide shows how Ethernet has evolved. This was the first thick Ethernet thing, okay, where a thick Ethernet is going and each computer is connected. Now later on it became next generation, which is called thin coaxial cable. So these are the computers. A wire will go inside computer to an interface, and this is how you are connect. Outgoing wire will connect to next one, and so on and so forth. This was next generation. And this is a modern Ethernet. So from your machine, a wire goes up to a hub or switch. Okay, from every machine, there are 100 machines, then all 100 machines will have a wire coming to this one. Okay, so this is the technology we use now. In your department, you can see how wire from your desktop, if not connected Wi-Fi, are going to a hub. Okay, or switch. We'll use the word switch now, not hub really. Any question? Okay, so this was the origin of the Ethernet, thick Ethernet. Okay, and of course there has got to be, if the multiple machines are there, each will have interface card. Each machine will have Ethernet interface card, and also will have source address and destination address, which is called Ethernet addresses. Okay, now if A has to send data to D, A will have Ethernet address, we call it EA, and this will have Ethernet, let's say ED. Now there may not be any relationship between EA and D. These are all flat addressing. If you bought this in India from one vendor, this you have bought in Singapore from some other vendor, it could be very different addresses. Okay, all right. So now A has to communicate to D. What is required? It has to know this address of ED, right? Only then it can send. All right. And similarly, when this D machine receives from A, it has to know it has come from A, right? So there is some kind of communication is required. We'll see how. So frame, the Ethernet frame which A will send to D will have source address or source Ethernet address, destination Ethernet address, and data. These are three minimum things that are needed, right? And of course, there are many more. And of course, the protocol that we use in Ethernet is called CSMS-AD. Carrier Sense Multiple Access Collision Detection Protocol, right? Okay, so when multiple computers are sharing a medium, like here, this medium, there has got to be a protocol how different machines are going to share the medium, right? Like this, in this class, I am talking right now. And if you want to ask a question, there has to be some protocol between two of us, right? Or many of us. What is that protocol? Anyone? What protocol in general we use? When I am talking, you will not talk in between, right? You will wait for some silence period. Only then you will ask questions. Okay. Now you are waiting for that period, and that period comes, and then you start talking, and I also start talking. What will happen? There is a collision. What will happen? One of us will stop. How much we are going to stop depends on us. Okay, and if next time again after a pause, if both of us start talking again there will be collision. So we have evolved some mechanism internally that this collision has to be reduced in some sense, right? All right. Similarly, protocol here has to reduce the collisions because anybody can communicate at one time. So there must be some rules, and these rules are called actually a protocol. And Ethernet started using CSMA-CD, which is still they use, but collisions are minimized. It's called carrier sense multiple access collision. Now carrier sense means that each one of these can sense that there is something going on or not. It means that when all of us, you can sense that medium is busy because I am talking. So that's a carrier sense. And if there is a gap, a silence, then all of you can feel that there is a silence. So they are able to, you are able to sense the carrier. Multiple access, multiple people can listen to me, right? Or here multiple computer can access the channel. Okay, and collision detection, it means that all of us have capability to detect that there is a collision between me and somebody who also starts talking at the same time, right? Note that most of the algorithm, 99.99% algorithm in internet or networking are distributed protocol. When we say distributed protocol means what? There is no central entity which will say now it's my turn and Ravi will talk for 5 minutes, then the guy will, somebody raises hand, then there is a, one who is managing it will say now this person will speak, then again turn will go to somebody else. There is no central entity who will define who will speak first or in what order, right? Everyone, when we say, other thing is that when we say distributed algorithm, everyone is executing the same algorithm. There is no central entity, right? And based on that algorithm, whole mechanism works. Okay, all right. Okay, so please go through this. Now let's jump over to CSMA CD. Very interesting protocol. Carrier sense and collision rate. These 2 points already we have discussed, right? Okay. Now if there is a collision, okay, this guy starts sending a frame. This guy also starts sending a frame, and it goes in all directions. This direction and other direction, because on physical media it will go here, and there's a collision. Okay, what will happen? All, and collision means that there is change in voltage level, so all will sense there is a collision. All this will sense there is a collision. Okay, as soon as there is a collision, when I am talking, you are all talking, start talking, and there is a collision, then both have got to stop. Okay, if the collision is detected, stop transmission. I will stop talking, and you will also stop if you're talking. Then if we say wait for say 10 seconds and start talking again, there will be collision. This means that now we have to wait for random period before start talking again. So after random period, I will see there is a silence, then I will start talking, because random number for both you and me would be different. So the very unlikely that there will be collision. So CSMA CD uses this method. The steps are as follows: NIC, network interface card. In your machine, there is a network interface card that runs CSMA CD algorithm. Okay, it receives, basically it receives packet from higher end, there's a network layer, and converts into frame. So NIC or network interface card senses the channel, right? Like, so this is channel and this is NIC of a computer. It senses channel. If it is a free or idle and it has frame to send, it will start sending the frame. The frame will start transmitting in this direction, because assuming this at the end. Okay, now if this channel is busy, it will not, it will wait until it becomes free. Okay, now if this guy, and this is the last guy at the end, right? Okay, at the end of wire, if NIC transmits entire frame without collision, it means that it has a frame to send, say for example 10 kilobytes. No, it could be less than 1000 bytes, 1000 bits for example. If this is the first bit to send and this is the last bit, if it completes the transmission and there is no collision, is done. Okay, if so, what if this card finds out there is another transmission by some guy here? Okay, it means that there is a collision. So it means that this NIC senses collision, it will abort and send a jam signal. Basically, it will send a jamming signal to all, so everyone will come to, those who even have not detected will come to know that there is a collision. Okay, what will happen now? After aborting, NIC, this NIC enters binary exponential backoff. Okay, all the, so this is the second NIC which has started sending, both get into binary exponential backoff. It means that after, okay, so basically if there is a collision, first collision, then it will wait for a random period between 0 to 2 raised power 1 minus 1. So this random period, if there is a second collision, okay, then this period will be different, right? So basically this will wait for certain period of time which is random in nature and then start transmission again. Okay, if there are if second time also if there is a collision, after waiting and picking up a random number and waiting for corresponding time, if we restart transmission, again there is a collision, then what will happen? This back off period m will increase. Say m becomes 2, then m becomes 3. After third collision, this back off period becomes larger. So probability of then collision reduces. Okay, all right. Now the question is that what should be length of the packet. There is some mathematics, right? The length of the packet, if packet is very small, right, then it will reach to other end, and if suppose this guy will finish transmission very soon if the packet is small, and in between this guy also starts transmission, okay, and there is a collision in between, this guy will, after finishing transmission of the packet, it will assume that I am done. Okay, so protocol will not work. So it has got to have packet length such that the last bit has to be sent, okay, after this first bit reaches towards the end, to the end, right? When first bit reaches the end, then it means that all nodes know that there is a communication happening, so there won't be any collision. Okay, please go through this. This is very interesting, and I will ask one question in the exam from this one. Now, what is the problem of thick Ethernet? Bulky wiring, error prone, difficult to debug, non-secure. You know, I mean, there's a wire running. It will run through building. And if I am a naughty guy, I will just remove this. I can go and do that, right? Or I will cut the cable. This is extremely error prone. Okay. A lot of security holes also, right? Okay. I am a malicious person. I can also probe and get a data from that. Okay, so now next technology was called 10 base T or hub technology, and the wires also changed to unshielded twisted pair UTP, and it's a hub and spoke technology, right? So it's like this. This is a hub. Now, if you look at it, what's the difference between here? It's colliding the signal here, right? It's just amplifier, nothing else. Okay, this thing, if you collapse, it becomes hub, right? Okay. So now this is the next technology where signals is exactly like bus or thick cable that we have seen, but this is collapsed. Now each individual laptop or machine will run a wire to hub. So it becomes star topology, but it becomes simple because this is less error prone. Okay, you're not digging a hole and then doing connecting transceiver and so on and so forth. And uses pair of UTP. There are two wires that run, for one for sending, another for receiving. Okay, so now this hub looks something like this. There is a repeater here in between. Whatever signal comes is amplified and repeated and sent to all. But it will have collisions. Okay, now question is that can we change this hub by switch? When we switch, it means that this is A, B, C, D. A wants to send it to C, it will come to switch, it will be in a buffer, and then it will send over to C. And at the same time, B wants to send to D, it will come here and it will be switched to D. There is no collision. Okay, this is what we are using now. Okay, all right. So there is active switch in the center, but still uses CSMACD, but no collision. Why do we use CSMACD still? Because if somebody changes it to switch to hub, it should still work for backward compatibility reason. Okay, all right. Now question is that how does it self-learn? You know, when A is sending data to A dash, okay, how does switch know where to send it to? A knows Ethernet address of A dash, but this switch is recently booted, it doesn't know where to send this data to. Okay, this is what is called self-learning. We'll just briefly for 2 minutes we'll learn this, and then we'll next class we'll look at into detail. Of course, we are going very slow. Okay, so this is a connection, right? This is how the structure is. Okay, of course the packet which each of these sends is buffered inside. Okay, and destination address is looked at, like A dash is destination address, then it will know that it's connected to 4 and send it there. But how does it know it's connected to 4? Okay, of course this transmission now can happen in parallel. Say A to A dash and B to B dash can happen in parallel. So there is no collision when there is a switch, yes, right? Okay, now question is that how do we learn? How does this switch learn about A is connected to 1 and A dash is connected to 4 and so on and so forth? Okay, what will happen? How does it work? It will create a table. This switch will create a table. It will have addresses, say A, MAC address A, MAC address A dash, B, B dash, C and C dash, right? And last is C dash, of course. These are MAC addresses. Now it has to know which port it is to connected, right? In the beginning, it knows nothing, right? So how will it know? Simple method is that suppose A has to send something to A dash, okay, it will create a frame. Source address is its own A, for example, A MAC address, A dash is destination address. So when it sends to this switch will know that A is connected to port 1. Okay, now it doesn't know where A dash is, right? What it will do, it will send it to all. It doesn't know where A dash is connected to, right? So it will send it to all, and in the process, because you know A dash will respond, okay, some acknowledgement frame or whatever, and in this way, now it will come to know that A dash is connected to 4. When this guy responds back, it will come to know is connected to 4. In this way, you know, all these tables are filled in. Okay, it's called self-learning. All right, okay. So I will send this to you. Please go through it, and then we'll continue from this point onwards. Okay, all right.